So what we looked at previously in 5.2, we're going to look at how we can use matrices to solve systems of equations. And so remember in the last section, we were talking about setting up a matrix A x equals B. What we're going to do is we're going to combine A and B into one matrix, and we're going to call that an augmented matrix. So when we look at something like this, 2 minus 1, 3, this is, instead of x, y, z, it's just x and y, and the 3 is the equals part. So as they've gotten down here, we look at this as 2x minus 1y equals 3. So this equation down here. So let's take a look at another example, maybe a little bit, so we have just this as a matrix. We can be the row -4 to 0. Okay, so just the coefficients here of x, coefficient of y, with what the equation is equal to. We have another equation. Remember, if there is no x, that must mean there must be a 0x. So when we go to put the matrix, we put that 0 in there for the x, -3 for the y, the coefficient, right? And what it's equal to is 1/4. Now, if this was a system of equations, we could actually put those together and have two rows, so forth. So we have the coefficient rows, which is just the numbers, x and y. And again, if there's a missing one, we've got a 0 coefficient. And then we have, here's an example. We put them together in a matrix where this 2 is coming from here. This -1 comes from the -1 in front of the y. The 3 comes from the 3 here. This gives us a -1, right? -1x, a 2, and a -4. And we call it augmented because these are our variable parts here, x and y's, and this is what it's equal to. When I was doing this back a few years ago, 30 or 40 of them, we would sometimes write a line here to indicate that that's where the equal sign was. And if you find it helpful, that's you're welcome to do that as well, recognizing that we're using this matrix in a special way now. Okay, so we can call it an augmented matrix, or sometimes we just drop the word augmented as it says, but we've got the answers as well as the variables there. Okay, so if we had a matrix, an augmented matrix, we could rewrite the system of equations. 2x minus y equals 3, -x plus 2y equals -4. Down here, same type of thing. X equals 2/3. And remember, since there's a 0 there, we don't need to put the 0y. Since there's a 0 here, we don't have to put the 0x, but the y here is 1y equals -5/3. What we just found out with this one is, notice these are the answers of what x and y are equal to. So when we get an augmented matrix that contains the identity matrix, notice 1 along the diagonals, what we end up, this is a solution to a system of equations. I don't know if it's the solution for up here. We're going to work through how we can actually do it, but this is telling us, when we have this particular one, that this is 1x equals 2/3 and 1y equals -5/3. So we've actually got the solution set here. That's what that's giving us. And that's basically what today's lesson's about. Part of it is we're going to need to, in your homework, you'll see you'll be given a system of equations, and we want you to be able to set it up as an augmented matrix, right? Write all the coefficients. So be able to do this part. A couple questions that's all that they're asking you to do. But the second part of that is we're going to ask you to solve this system using the matrix method. That's what the rest of this lesson is about. How do we do this? Well, first of all, we're going to put a system of equations into a matrix. So notice I've got the negative 2/3, the 1/2, negative 3. One of the things we find, though, the matrix operations we can do, remember, we're really working with equations. So we can do anything we can do to equations, we can do to a matrix. And so one of the things we do with equations when we have fractions is we multiply by the common denominator. In this case, if we multiply both sides by, and we have to multiply both sides of the equation, right? Whatever you do to one side, we have to do the other to keep it equal. If we do that here, we'll get rid of the fraction. This will distribute to both these terms. So we'll have 6, 3 goes into 6 2 times, and we'll have 6 here. 2 goes into 6, so we'll have 3 left. So we'll have, this equation would have become minus 4x plus 3y. 6 times negative 3 is negative 18. We're going to see that that's what we're going to end up with here. Same thing down here. Fractions are sometimes more difficult to work with, so we would multiply both sides of this by 4. Again, the 4 would transfer or distribute to both of these. 4 divided by 4 is 1. We get a 4 here, so we're going to get x minus 4y. 4 divided by 4 is that equals 11. So that would be our other equation. So one of the ways we can write this is we say, okay, let's just take 6 times row 1, and we're going to install that there. We're going to take 4 times row 1, and we're going to install it there. And so they did it all for us like this, right? And then what we're going to see is we're going, this 2/3 is now going to become negative 4. 1/2 is going to become 3. Negative 3 will become negative 18. So we got that right here. And likewise, the bottom row became 1, negative 4, 11. So we're just multiplying basically both sides of an equation by the same thing, but we're doing it in a matrix form. It's a little bit more abstract, but it's one of the things we can do. We can multiply a row in an augmented matrix by any number, and that will make it easier for us. Okay. We didn't need to do this. We could go ahead and solve this using these fractions, but I think if you're like me, it's a lot easier to work with integer values rather than fractional values. So let's go through solving how this works. Remember what we're looking for. But first of all, we'll set this up. What we're looking to do is get a 1, 1, 1 down the diagonal, and then zeros everywhere else. And then these will become our answers over here. So that's the whole process of what we're going to do. The text introduces this idea of doing a pivot. And what they're going to do is, the first thing they're going to do is they're going to try to get, starting with the first column, try to turn both of these into zeros. Okay. And we will be able to do it by, the other thing we can do is we can, since it's a system of equations, we can add one equation to the other equation. And so we can multiply an equation by the same number, right? And then we can add that equation to another one. So what we're going to do is we do work off the pivot. We've got the number 1 here. We want to turn this 3 into a 0. So one way of doing that is to take row 2, and then we're going to subtract from it 3 times row 1. Okay, so I'm going to, and again, you've got some scratch work that you're going to want to do somewhere. So 3 times row 1, I'm going to do that right over here. And so I'm going to take 3 times each of these numbers. 3 times 1 is 3. 3 times -1 is -3. 3 times 5 is 15. And 3 times -6 is -18. Okay, so I took each of these times 3. I'm going to then subtract this row from row 2. So again, I'll write row 2 up here. 3, 3, -1, and 10. Now we're going to subtract, so that means that this becomes negative. 3 minus 3 is 0. Subtracting, so this becomes positive. 3 plus 3 is 6. This becomes negative. -15 and -1 gives us a -16. This becomes positive. 18 and 10 are 28. What you'll see is those are the numbers that they've come up with in this row. But it seems a little magical to just look at this and say that this row became that. Now, row 1, they just copy over. Okay, so this all just gets copied over here. But these are the new values in our matrix. And notice we've got that 0. For the bottom row, what they're going to do is this is sort of what's going to happen. They're just going to take row 3, which is this bottom row here, and subtract off row 1. So they don't do any multiplication, but row 1 gets written 1, -1, 5, -6. I'm going to write row 3 here as 1, 3, 2, and 5. And again, we're going to do this with sort of a we're going to subtract row 1 from row 3. So 1 minus 1 is 0. This becomes a plus. 3 plus 1 is 4. This becomes a negative. 2 minus 5 is -3. And a negative and negative become a positive. This becomes 11. And you'll see those numbers right here. So they get moved over to the matrix. So we now have a new matrix. It is equivalent to the first matrix. And so again, we could take the row we want to change. We may need to multiply it by a number. In this case, the row we were changing didn't need to get multiplied by anything, only the row we were using as our pivot row. So we used row 1 as our pivot row. Got zeros all the way down. Next step we're going to look at doing is we're going to want to get zeros above and below in column 2. And then we'll want to get these two turned to zeros. And then the last step is to work to get the middle, the diagonals, all to be 1s. And in that case, if we ever end up with fractions, we'll usually end up with it on the last step. Okay, we'll see. We'll be able to get these zeros as we go. So that's the whole process. Get zeros above and below, or just above, or just below, however it is. Get the zeros everywhere. And then on the diagonal, we will be able to change all of these to 1 by division. Okay. So let's keep going. So what they're going to do now is, well, one thing we can always do, we don't have to do this, but if you notice this middle row here, right, 6, -16, 28, it can reduce because we could divide each of these by 2, so we're dealing with smaller numbers. It just makes it easier. So 6 divided by 2 is 3. 16 divided by 2 is -8. -16 divided by 2 is -8. 28 divided by 2 is 14. So we do that just to reduce it down. Again, not necessary, but it just is going to make it a little easier for us. Okay, smaller numbers to deal with. Next step is we're going to now, so this is our new matrix, right? It's equivalent. We don't really need this one, the first one anymore. So we're going to start with this one. And again, we're looking to get zeros above and below in these places. So one way to do this is, since we've got a -1, we've got a 3 here. If we took 3 times row 1 and then added 2, because this is negative, right? This would become -3, and we add these together, we get a 0. So what are they doing? They're going to take they're going to take 3 times row 1, so that'll give us 3, -3. I'm taking row 1. 5 times 3 is 15, and 6 times 3 is -18. We're going to take row 2, so we copy row 2 right below it, and we're going to just add these together. 3 and 0 are 3. This is -3 and 3 are 0. 15 minus 8 is 7, positive 7, and -18 plus 14 is -4. Now this is going to get stuck up in row 1. Now don't be too fretting. You think, oh, we already had a 1 here, now it became a 3 because of what we did. That's okay. We're going to see we just want to get zeros above and below. The main thing it did for us is it gave us this 0 in the place we need it. Okay? That's the new thing it did. All these other numbers we don't care about, and so far these have remained 0. They always will. This is how that works. So the next step is we want to get this turned into 0. Well, 3 and 4, what we're going to need to do is take row 3 times 3 and row 2 times 4. So 3 times 4 is 12, 4 times 3 is 12. So basically getting a common multiple, right? Or using them, multiplying them together. And then we're going to subtract them because they're the same sign. So 3 times row 3. So here's row 3. Come over here. So 0 times 3 is 0. 4 times 3 is 12. -3 times 3 is -9. And then 3 times 11 is 33. And we will take row 2 and multiply it by 4, and we're going to subtract it. So this way, you could multiply it by -4 and then add it. However you want to do it. I'm going to take 4 times 3 and get, 4 times 0 is 0. 4 times 3 is 12. 4 times -8 is -32. And 4 times 14 is 6, carry the 1, 56. Okay. And then we're subtracting this from that one. So 0 minus 0 is still 0. 12 minus 12, that's 0. We're subtracting, so this becomes a plus. -9 and 32 is going to give us positive 21. And then we're subtracting, so we're going to end up with 3 to -23. Let's see what I do here. 32 and -9. Oh, yeah, that's not 21. I went too far. I went the other way, 23. Double check. So that's what we got here. And again, the important part we added here is we've got now a 0 in this position. Next step is what we want to do is we want to get zeros here and here. And then we're going to be set up to do our last and final step. However, you're going to see that at 23, 23, we could divide this, again, just kind of cleaning it up. So that's what they notice. Oh, there's 23 and 20. So if we divide by 23 or multiply by 1 over 23, we get a new matrix. It's just a little easier to work with 1 than it is with 23 and try to get a common multiple between 23 and 8 and 23 and 7. This matrix you're going to see is going to be so much easier to work with. Okay. So we select the pivot in the third row and clear its column. So we want this row, and what we're going to do, you see here, we just need to multiply this by positive 8, add it to here, we'll get a 0. Multiply it by negative 7, add it here, we'll get that. So again, and you can go kind of in any order you want, but to get the top one cleared, we're going to take row 1 and we're going to subtract 7 times row 3. So we just copy row 1 is 3, 0, 7, negative 4. We take row 1 and we're going to multiply it by 7, 0, 0. And then 1 times 7 is 7. Negative 1 times 7 is negative 7. We're subtracting. 3 minus 0 is still 3. 0 minus 0 is 0. Negative 7. 7 minus 7 is 0. That's what we wanted. This becomes a positive, so we get a positive 3. It's this top row here. For the second row, we're going to take row 2 and we're going to add 8 times row 3 because the sign is opposite. So again, we just copy down row 2, 0, 3, negative 8, 14. And we take 8 times row 1, 0, 0. Notice it just gets easier as we get these zeros filled in. 8 times 1 is 8, and 8 times negative 1 is negative 8. We're just going to add these together. We get 0, we get 3, we get 0, and we get 7. Oh, 14. 7, 6. 14 minus 6. Okay, I'll wake up here. 14 minus 8 is 6. Okay. Good thing I left these here. So this is the new row we get, right? 0, 3, 0, 6. That's what we put in there. And now notice we've got a row that's got all the zeros where we want them. And we've got this diagonal going. And now the last step is to turn all these diagonals into 1, which is a very easy thing to do. We just divide by it. So we're going to divide by 3, divide by 3, divide by 1. Actually, this one, nothing to do. And again, if there were going to be fractions, these things would end up being fractions. But as we're going to see in this case, it's not going to. So the top one, divide by 3, we get 1 and 1. The middle one, we divide by 3, so we're going to get 1 and 1. Or sorry, 1 and 2. And then the last one, we don't have to do anything for. But what it tells us is that x equals 1. X equals 1. Y equals 2. And z equals negative 1. So we've got our answers right there, which they've got written out horizontally here. Now, I just want to show you how to do this with our graphing calculator. So I'm going to pull this up and let's back it up a bit. The original, I'll leave it there. I'm going to bring over the graphing calculator and show you how we can even oh, that's right, I've got to get this, we'll keep it a little bit bigger. And then now I can bring my calculator over. So we want to enter this in as an augmented matrix. And we can just do that. Second matrix. We'll put it into C. Actually, go over to Edit. And our matrix is going to be 3 rows by 1, 2, 3, 4. So it's a 3 by 4. We're going to enter in 1, -1, 5, and -6. We're going to enter 3, 3, -1, 10. We're going to enter 1, 3, 2, and 5. Again, we're going to see that this will handle it all for us, but at the same time, we need to know how the matrix system works. Okay, I'm going to do second quit. To do this, what we're doing is called reduced row echelon form. What you'll need to remember, we go to matrix, we're doing math, and if we go down this list, there's something called RREF, not REF. REF is just reduced echelon form. It's not reduced row echelon form. So we want the RREF, or simply B, I guess you could enter that. What we're going to say is, give me reduced row echelon form of the matrix I just put in. So then I come back and I go to matrix. And this time I'm using the name, so I go to C. I'm going to put C into reduced row echelon form. I'm going to hit enter, and all those pages of work we did is accomplished in a very short period of time. X is equal to 1, Y is equal to 2, Z is equal to -1, just like that. Okay, so again, we've got technology that will help us get to our answers, but we also want you to be able to go through the process. Okay, so let's come back here. We ended up with, so the whole process is to get ones in the diagonals. Again, we do that first. We start getting zeros up below and above, and above the diagonal, below the diagonal, and this is going to be that x equals whatever number's there, and so forth. Okay, so this system can be solved. Again, we didn't get this far, but maybe I should kind of continue. Because there's a few things that can happen, and actually I'm going to pause it here, and we'll finish this up on Tuesday's class. We're going to look at what an inconsistent system is. What's one with infinite number of solutions. So there's ones with no solutions, infinite solutions, and then what we came up with is one particular solution. So, but this is about as far as we got in class. So I'm going to stop here for now, and we'll get the rest during